This is the chemistry revision for weeks 1 and 2 in semester 2. In this PowerPoint presentation, we revise the following points: the properties of metals and non-metals, the definition of molecules, the molecular formula of a molecule, classification of molecules according to the number of atoms, classification of molecules according to the type of atoms, atomicity of a molecule.
Physical properties of metals and non-metals. Let us discuss the physical properties of metals. All metals exist as solids at room temperature. Example: iron, lead, zinc, and copper. Mercury is an exception. Metals are good conductors of heat. Silver and copper are the best conductors of heat, whereas lead and mercury are comparatively poor conductors of heat. Metals are good conductors of electricity also. This is the reason why electric wires are made of metals, like copper and aluminium. These wires are insulated with polyvinyl chloride, that is, PVC, or a rubber-like material, to avoid electric shocks. Some metals have the ability to be beaten into thin sheets. This property is called malleability, that is, metals are malleable. Gold and silver are the most malleable metals. Also, they have the ability to be drawn into thin wires, which is called ductility. Gold is the most ductile metal. Metals are generally hard, and its hardness varies from metal to metal. But metals like sodium and potassium are exceptions, as they can be easily cut with a knife. We find that metals, in their pure state, have a shining surface. This property is called metallic luster. For example, gold, silver, aluminium, and copper. Moreover, metals produce sound when they strike a hard surface. So, they are said to be sonorous. As such, school bells are made of metals. Metals generally have high melting and boiling points. For example, iron. Metals also have high densities, due to which they are heavy. For example, iron. Exceptions are sodium and potassium metals, which have low densities. Now, let us discuss the physical properties of non-metals. Non-metals are either solids or gases, for example, sulfur and oxygen. But bromine, being a liquid, is an exception. Non-metals are poor conductors of heat and electricity, for example, coal, which is a form of a non-metal carbon. But graphite, which is another form of carbon, is an exception, as it is a good conductor of electricity. Non-metals break easily, which means that they are brittle. Thus, non-metals are non-malleable and non-ductile, as they cannot be drawn into thin sheets or thin wires. Non-metals are generally soft. For example, sulfur. But diamond, which is a form of carbon, is extremely hard, and, hence, it is an exception. Non-metals, in their pure state, do not have a shining surface. This means they are not lustrous. For example, sulfur. Iodine, which is lustrous, is an exception. Also, non-metals are non-sonorous, as they do not produce sound. For example, sulfur, iodine, etc. Non-metals generally have low melting and boiling points. For example, sulfur. Except diamond, which is a non-metal, having high melting and boiling point. Non-metals have low densities, that is, they are light substances. For example, sulfur, whose density is 2 grams per centimeter cube, which is quite low. Hence, we can differentiate between the physical properties of metals and non-metals, as shown.
What is a molecule? Badia, read the definition of a molecule, please.
What is a molecule? A molecule consists of a group of atoms binding together and acting as a single unit.
So we have like the water molecule, we have the oxygen atom, the hydrogen atom, and hydrogen. So 2 hydrogen atoms binding to 1 oxygen atom, forming a water molecule. So we stop saying oxygen, hydrogen. Now they are acting as a single unit, which is water, so a water molecule. Same for ammonia, carbon dioxide, and methane. They all have different types of atoms, but they act as a single unit. So this is a molecule. Molecular formula, it should show the number and type of atoms in a molecule. For example, butanol molecule consists of 4 carbon atoms, 10 hydrogen atoms, and 1 oxygen atom. Write its molecular formula. So we start with carbon, it's C, it has 4, hydrogens H, yes, it has 10, and oxygen 1. Do we write 1? No. So in a molecular formula, we don't write 1. So this is called a molecular formula. It shows the type of atoms, carbon, hydrogen, oxygen, and their number. Classification of molecules according to the number of atoms, we have 3 types: diatomic, triatomic, polyatomic. Diatomic if it has only 2 atoms, like oxygen, O2, like HCl, and so on. Triatomic, it should have 3 atoms, like carbon dioxide, or O3, ozone, and so on, or H2O. Polyatomic, more than 3. Like H2SO4, or methane, CH4, and so on. Another classification for molecules is according to the type of atoms. We have the molecular element, molecular compounds. Molecular element where we have identical atoms, so we don't care for the number. We should have identical atoms like in O2 or N2 or O3. Molecular compound, we have different atoms. We don't care for the number. So we have different atoms like in carbon dioxide, or in HCl, or CH4, or H2O, and so on. Atomicity, it is the total number of atoms in a molecule. For example, sulfuric acid consists of 2 hydrogen atoms, so it's H2, 1 sulfur atom is S, 4 oxygen atoms is O4. Finding the atomicity, Muhammad Saleh, can you give us the atomicity of H2SO4? Equal 2 plus 4 plus 1 equals 7 atoms.